for a more detailed discussion on this, I refer you to what architect Edison Ching Padilla and architect Ferdinand Estepa has written in 2015. So this was the first edition, and the title is An Architect's Illustrated Guide to RA Republic Act 9514. 9514 is our Fire Code of the Philippines of 2008. Fire Code of the Philippines of 2008 and its implementing rule. Primer and means of egress. Okay, again, the authors are architect Edison Ching Padilla and architect Ferdinand B. Estepa. Architect Edison Ching Padilla is the incumbent building official of Valenzuela City. So, he gave me this in 2017, November 2017, to Engineer William Juan. Practice fire safety, always enjoying hearing your talks and lectures. And signed, Architect Ching Padilla. So I'm very thankful that Architect Ching Padilla has also been doing lectures at the MEP Center before, and he continued to advocate. He is a colleague in the lectures in the capacity building of the PWH, Office of the Building Official. I mean, the Philippine Association of Building Officials usually conduct this capacity building for their inspectors and building officials, and Architect Padilla is the speaker for fire means of egress or fire, and yours truly is the usual speaker in electrical regulations. Now we proceed to fire detection and alarm system, which, like I mentioned, this is the system that would save lives, including the toxic gas detection and extraction. So FDAS is mandatory, should be, not only in buildings. In buildings, about 97% of commercial buildings has this, but homes only 17% has. So again, my suggestion for the Bureau of Fire and the Office of the Building Official is to come out with an IRR that should expand the implementation of the FDAS, not only for the buildings or commercial buildings, but also for the homes.
1B.1. Why is FDAS required? Why are fire detection and alarm systems required? To detect fire in the areas, to notify building occupants to take immediate evasive action, to escape the danger of a hostile fire, to summon organized assistance to initiate or assist in fire control activities, to initiate automatic fire control and suppression systems, and to sound the alarm, to supervise fire control and suppression systems, to ensure operational status is maintained. Initiate auxiliary functions involving environmental, utility, and process controls.
FDAS, fire detection and alarm, includes this block diagram where you have the original here, a smoke detector, then heat detector here, and a manual pull station, meaning just a push button station. When you break that center and then you push it, then you are actuating an alarm. So this one is a manual thing, this red box here, red rectangle. But this one, smoke detector, is an automatic thing together with this heat detector. They are both automatic. The moment they detect smoke or heat, they give this signal to this center equipment here or box, which is the control panel, and the control panel, since it is a logic device, will send a signal to your buzzer and light and hoter or whatever to actuate an alarm. And even you can also automatically operate smoke extraction, air pressurization, and others. Of course, here I have included in my suggestion the provision of toxic gas detectors, which is my baby, like I said. Carbon monoxide, hydrogen sulfide, which of these two are toxic gases. And LPG is highly flammable, and of course CH4 is methane, highly flammable. So this must be provided these detectors must be provided so that we can ensure higher level of safety for our buildings and facilities.
1B.3 Criteria for FDA's Layout 1. Criteria to determine the layout of fire detectors. The design, construction, and operational features of all types of detectors shall be by relevant standards. The number of fire detectors to be installed is governed by total area to be protected, type of building construction, air movement and air velocity, ceiling obstructions, concentration of equipment in the area covered, sensitivity required. The area is divided into zones to be protected. The zones of individual detectors must overlap and no blind zone shall be left. 1B.4 Criteria for FDA's Layout 2. The areas above the false ceiling and below the false flooring will be considered as separate zones. Under ideal conditions of a smooth ceiling and average room size, one detector is recommended to protect the area. The ionization type detectors should be located where the largest combustible gas concentration can be expected. In an air-conditioned area, both ionization and optical type smoke detectors are used. Detectors must always be installed at the highest point of the ceiling, with the minimum coverage as indicated by the manufacturer shall be considered. The number of detectors and their location should be carefully selected so that complete coverage is ensured. 1B.5 Criteria for FDS Layout 4. Initial quantity estimate of smoke or heat detectors. 35 to 40 square meters per detector for general application. 20 to 25 square meters per detector for the main control room, electronics cubicle room, computer room, etc., because of high value concentration. The exact requirement shall be calculated based on the relevant IS or NFPA standard.
Okay, so there are two types of fire detection and alarm system. One is the conventional type, and the other one is the addressable type. The difference between the two is that the conventional type is an analog system, analog system. So it works like on a switching, like ordinary relays and ordinary switches. Okay, while the addressable type works with computers. So it has a central processing units. It has a video monitor, and the detectors are all using digital communications, and there is the binary system that is being used between the detector and the computer system. So you cannot use components in a conventional system to an addressable system, or similarly, you cannot use components in an addressable type like detectors and output devices in a conventional system. They will not work. Okay, conventional. So between the conventional and the addressable type, they are just simply the same. Except that, like I said, the addressable type has a computer, and this one doesn't have a computer. This conventional. Of course, conventional is a lot cheaper than the addressable type. Okay, so for a 4-story building, which would have maximum of 8 zones, the cost of the fire alarm control panel for the conventional would be something like 100,000. But for an addressable type, for that equivalent could cost 60,000 more, so 160,000. So something like that. So of course, the addressable type is now being used for bigger buildings like malls and high-rise and so on, because it has the capacity to provide a more accurate protection, safety and protection for your occupants. Okay, so here is a general requirements for conventional FDAS. Okay, I'll not discuss in detail. And here is for an addressable. As you will see, the applications are more. like industrial and non-industrial buildings, institutional buildings like hospitals and so on, residential apartments, so high-rise, hotel and hospitals, all industries, malls and multi-storied complexes. So when you say complex, it's a mixed use, offices and control rooms. So there are more areas where this addressable type is being used. And like I said, the addressable type uses a microprocessor or a CPU. Okay, and benefits of the FDAS addressable type are mentioned in here. Continuous supervision of the devices, discrimination between a false fire and a real fire, and then individual detector addressing or communicating capability, detection of over and under sensitive detectors, pre-alarm case of any detector. Meaning to say, if one detector is defective, then it can do an alarm. While in the conventional, you will never be able to know it, not until you're going to test it, actual test, and it's not functioning. No? And facility shall be provided for alteration program. So it can easily be maintained, because you can, the CPU, the central processing unit, or the computer, can be made to communicate with the different components in the system. No? Okay? And here is one of the input devices, the manual police station. At a closer look, there is a glass here, which you have to break in case of emergency and push the button so that it will cause a switching and it will actuate an alarm. And of course, you have the other automatic devices like the heat and the smoke detectors. Here, heat detectors, smoke detectors, and you also have flame detectors. Of course, flame detectors, it's already late. This is already flame. Your heat detector is much better and than the smoke detectors, because the heat detector, before you have a fire, it detects already the presence of an abnormal heat that may be happening inside the room. No, and smoke, there is already a fire in here. No, flame is worse because it's already a big flame. Okay, fire gas detector is the same. You already have a gas, so you must have something like a toxic gas detector. No, okay. So here are just the description for the heat detector. No, fixed temperature type and rate of rise heat detector. Okay, and now we go to the photoelectric detector. So smoke detector, photoelectric in nature. This is the most common detector. And the ionization smoke detector. So a little difference in the operating characteristics. The ionization is more, it's a lot more expensive, but it is more, it's more, what you call this, sometimes suited best more for some addressable applications. No? And then, of course, the output devices like audible alarms. You have sirens, bells, buzzers, horns, voice drivers. So these are all sounds, sound alarms. Okay, an audible alarm signal lets people know the alarm system has been activated. Devices may be mounted inside or outside based on level of protection required. Okay, and the next one is visual. So this one is the sense of hearing, and this one is the sense of seeing that I told you. So a visual signal lets users know the status of the alarm system if activated. Visual devices may be mounted inside or outside. May it consist of strobe lights, so it's and LED lights, strong LED lights, on and off printer. What else? Rotating beacon. A rotating beacon is the one that is installed on top of the police car. A rotating light. Okay, and this was the one that I mentioned regarding a smartwatch system, similar to this. So this watch has a SIM card inside, and it could receive a signal from a computer or from a fire alarm and control panel that is addressable type, and it would vibrate. Of course, you can also use your smartphones because the smartphones has a SIM card. So your addressable type or your CPU in the addressable type will also send a signal to your smartphone. But the problem is we do not usually have our smartphones in our pocket when we sleep. So my suggestion is to use smartwatches, which many of us would wear when we sleep. No, although some of us would remove it. But when you have this, and you have that protection in the building, of course you have to wear it because you will have a higher level of protection. No, like I said, you have already the sense of hearing by the alarms, and then the sense of seeing by the lights, and the sense of feeling by the vibration that this could produce. Okay? Now we have these codes that govern the practice of or the provisions of FDAS, Fire Code of the Philippines 2008, and then Philippine Electrical Code Part 1, Philippine Electronics Code Book 2, FDAS, NFPA 72, National Fire Alarm and Signal Code, Signaling Code of the US, UL, Underwriters Laboratories, and other standards, worldwide standards. And these are just abbreviation for that you may see in typical FDAS plan. You have FACP, meaning to say Fire Alarm Control Panel. RAP, meaning to say Remote Annunciator Panel. SD means Smoke Detector. FD means Flame Detector. MPS means Manual Pull Station. SS means Supervisory Switch. SL means Strobe Light. EOL means End of Line. This is the resistor that is connected in the circuit of the smoke detectors. And UV means ultraviolet light. CONV is conventional, and HD means heat detector. FGD means fire gas detector. FS means flow switch. FAC means fire alarm cabinet. AB means alarm bell. CP means call point, so there's a phone there that is provided. IR means infrared light. And ADD means addressable. So this is the difference between the conventional and the addressable type fire alarm control panel. And here is just a typical circuit, how an FDAS circuit would be shown. So you have here a layout of a floor plan. And you have here rooms. So this is one room, a bedroom, 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 bedroom. So there are two units, two bedroom here, and there is this sala. This is the living room and a kitchen, dining and kitchen area, and two bedrooms. And then you would have smoke detectors interconnecting this, here. All of these circles are smoke detectors. This one, and this one, and this one, and of course this symbol here, green symbol, is the fire alarm control panel, and you will see a buzzer here, a bell and a buzzer to initiate the alarm. Okay, so that's the usual plan. And to show the vertical riser, you would show like this, a one-line diagram showing here these circles are the smoke detectors on the second floor, and here are the smoke detectors on the ground floor. And fire alarm cabinet here, and here you have our remote annunciator panel here, and of course the buzzer, and here is the fire alarm control panel. So that's for a two-story building. For a higher building, you would show it like this. Say for example, you have three-story building. This is ground floor, and this is mezzanine, and this is second floor, and this is third floor. Or if you have more floors like fourth, fifth, sixth, and so on and so forth, you just simply indicate the risers. Okay, and again here you have SD here, smoke detectors, and of course all the other components that we have indicated earlier, including the schedule of wires, symbols, notes, construction notes. Okay, and again that's how it's being presented. So we have done already the fire detection and alarm system, we go to this next topic, which is my baby, like I said, toxic gas detection and extraction. But before we continue on, let's have a short break. Okay, we are back. Let me greet those on the chat box for a few moments. We have here John Docos again. Good evening, Sir Will. Good evening. And London Sisters Channel. Good evening, sir. Charles August from Zambales. Good evening, sir. Pwede po ba makahingi ng copy nitong person? Yes, of course. JCG. Good evening po, sir. And Lino Hernandez is also here. Good evening, Lino. How are you? And then, of course, Ten Apolinario. Good evening, sir. Willie. Then, Richard Regidor is also here. Good evening, Sir Will. Then, okay. So, thank you. Just post your questions that we'll try to answer as we go on later. So, now we proceed with my baby. I always say it's my baby because after the incident of the Resorts World incident in 2017 in June, in just a few months, I have established that the reason for that for the death of about 37 people was the poisoning due to carbon monoxide. So let's go back. Programmable, flammable gas sensors to prevent possible explosion or fires. Fire gas detectors monitors level of carbon dioxide and carbon monoxide, and they are common to all fires, especially inside enclosed spaces. More discriminating than other detectors, can be designed to be sensitive only to gases produced by specific types or hostile fires, and ignores gases produced by friendly fires. Not many in use, very specialized applications. So you see, in the world, these carbon monoxide or toxic gases are only a few, and that's why many of our buildings are not yet provided with this, and that's why I'm saying it as my baby, because I'm trying to awaken the Bureau of Fire people and the Office of the Building Official, the LGUs, that we should now upgrade the implementing role of the Fire Code of the Philippines to include already this toxic gas detection and extraction that I'm talking about, that it should already become mandatory. Okay. And now again, we discuss about carbon monoxide. Carbon monoxide is a colorless, take note, carbon monoxide is colorless, odorless, tasteless, flammable, toxic or poisonous gas, and is slightly lighter than air. No, so do not make a mistake of thinking that it is carbon dioxide. Carbon dioxide is the one we exhale. When you exhale, we bring out carbon dioxide, and the plants need the carbon dioxide. Okay? While the plants also give back the oxygen that we breathe. But carbon monoxide is 1 part oxygen. In carbon dioxide, you have CO2. No? So there's 2 parts oxygen in there. 1 part carbon and 2 parts oxygen. While in carbon monoxide, you have 1 part carbon and 1 part oxygen. And that makes it poisonous or toxic. Okay? So, carbon monoxide is produced during fires in enclosed areas. So, if you have a fire inside air-conditioned rooms, enclosed rooms, then chances are you produce this carbon monoxide. Okay, it is present in enclosed or partially enclosed buildings. When there is not enough oxygen inside and there is a parked vehicle running, chances are you also produce carbon monoxide. So what is the solution to this? You must have detectors. This is the only way, no? We must have carbon monoxide detector, and they should actuate an alarm, and they should run automatic extraction fan or exhaust fan or ventilating fan, so that this carbon monoxide will be flushed out from the room. Can a person smell it? Like I said, it's colorless and odorless. So only a detector, carbon monoxide detector, can detect it. Okay? Otherwise, then if you do not provide for this, then more people will die if there is a fire in an enclosed area. Of course, if the fire happens in an open area, chances are the carbon monoxide that is produced is very small, not really a big problem. Okay, maybe it's more of the smoke, the bad odor of the smoke that may affect those people inside a burning building, but it is not totally enclosed, no? When I mean totally enclosed, those buildings like the Araneta Coliseum, the Mall of Asia Arena, you have the SMX Convention Centers, you have the Terminal 3 in NAIA, Terminal 2 in NAIA, even the Terminal 4 or Terminal 1. All of these are enclosed spaces. Theaters, mga sinehan, convention rooms, conference rooms. So, even a small room, no? If there is a fire, then chances are if you remember the fire that killed the daughter of the former speaker, no? It was a house in Forbes, air conditioned, and when fire broke out, I think it was the Christmas lights, something wrong with the Christmas lights, the quality maybe. So then it produced carbon monoxide because the house is air conditioned. And the child ran for safety to one of the rooms upstairs. Unknowingly, the carbon monoxide was continuously being produced by the burning. Okay? And then the carbon monoxide would then follow her to the bathroom where she took shelter, no? So there. If the house would not have been air conditioned, no? If it is just simply open, then chances are there would be lesser chance for producing the carbon monoxide. So that's the problem. If you have an air conditioned room and it is totally sealed, big danger. If there is a fire, chances are you produce carbon monoxide. But if there is a little awang-awang, that means air can come in and go out. But of course, you will lose cold air. We don't want to lose the cold air, so we want our air conditioned rooms to be very tight, So that's the big problem. So the only way is you must have a detector that will sound an alarm and run exhaust fans. So that's the only way. There's no way for it to solve this problem. Okay. So this is my explanation. I will not discuss it anymore. You can just read it later. Now, we proceed with hydrogen sulfide. So, I'm talking about toxic gases. No, the second one is hydrogen sulfide, very dangerous also. How is this produced? Well, the hydrogen sulfide comes from gas from the septic, no? A hydrogen sulfide is colorless, corrosive, flammable, toxic, or poisonous gas. Take note, it is colorless, corrosive, flammable, toxic gas. Of course, it is not without a smell. As a matter of fact, it is with a bad smell, no? Mabaho. It smells of a rotten egg. So when you smell this rotten egg, then there is hydrogen sulfide. And of course, one thing good is that it is slightly heavier than air, just like LPG, just like methane. They are heavier than air, so they occupy a space nearer to the floor, no? Not to the level of our nose, but of course they may be there if there is plenty of it produced, just like what happened with the Glorieta 2 explosion years ago, 2007 or 2006? Okay, so the basement floor, they have bathrooms in there, or restroom. The sump pumps were not properly maintained, so they produce methane and hydrogen sulfide, which caused the explosion. So hydrogen sulfide is present from natural gas, no? So also in LPG, also in crude oil, also in the refinery, in the septic tank, there is there. So therefore, in the home, there is a possibility that it can enter the home when the trap seal in the plumbing system is lost, no? So meaning say the water inside the P-traps are lost, or in the floor drains, the water is lost there due to evaporation, then you run the risk of creating this poisoning coming from the hydrogen sulfide. But one thing good, like I said, is that may smell siya. There is a bad smell which should sound a person, should give an alarm to a person. But the big problem is, even if you can smell it, that will take a little longer time for you to be able to smell it, because our nose are located higher, no? If only our nose is, there is also a sensor in our feet, meaning to say, if the feet is provided with a sense of smelling, so that it could detect the presence of this poisonous gas as low as which is close to the floor, then that would be a lot better, no? But God only gave us the nose in our head. Unless you are lying down, you are lying on the floor, very close to the floor, or prone to the floor, then your nose is near the floor, then you can easily smell this heavier than air, no? Slightly heavier than air. Okay, just like LPG, methane, hydrogen sulfide, all of these three gases are heavier than air. Okay, an example of hydrogen sulfide gas that is being vented to the atmosphere, no? So in the gasoline station, they provide these vents so that the hydrogen sulfide would just be diffused through the top of the vents, no? That's how it is being vented to the atmosphere. Okay, LPG is also a dangerous gas, so it must be provided with a detector. Here is a detector, and here is a solenoid valve, an electrical solenoid valve that will automatically shut off the flow of LPG gas to an appliance like a LPG burner, okay, or maybe a dryer for a laundry or other purposes. Okay, so, and here is methane. The characteristics of methane is also similar to LPG, highly flammable, but not toxic. Remember, LPG and methane are not toxic gases, but they are highly flammable. Take note, highly flammable. So the moment you create an ignition, then pop, suddenly you would have a big explosion. And this is the same cause of the fire at the Glorieta. Okay, while the fire at the or the explosion that happened in the Serendra was caused by LPG gas leak at the Serendra in Bonifacio Global City near the market. Methane gas was the reason for the explosion at the Glorieta 2 in 2006. And here is my illustration on how to protect against these gases. So you must have CO2 detector. This one is the CO2 detector, and this is your H2S, methane, and similar LPG detector. And of course, you have to provide this carbon monoxide toxic gas extraction fan. So these fans, extraction fan, must be installed at the ceiling, must be mounted on the ceiling. And like I said, when the detector detects it, it will send a signal to the fire alarm control panel or your logic device, and the logic device will send signal for the extraction fan to run or operate, so that it will remove the toxic gases from inside the room or from inside the enclosed space. Okay, so that's how we should solve this problem on toxic gas detection and extraction.